With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the question is, a sphere of mass 20 kg is suspended by a metal wire of unstretched length 4 meter and a diameter 1 mm. When in equilibrium, there is a clear gap of 2 mm between the sphere and the floor. The sphere is gently pushed aside so that the wire makes an angle theta with the vertical and is released. Find the maximum value of theta so that the sphere does not rub the floor. Young modulus of metal of the wire is 2.0 into 10 raised to the power 11 Newton per meter square. Make the appropriate approximations. Okay, so basically this is the situation as shown over here, that there is this ball. So this is the situation where this string of length 4 meter, yes, exactly, the string of length 4 meter is hung, and there's a ball of 20 kg at one end of it. The gap between the ball and the floor is 2 mm. The ball is shifted aside to an angle theta such that when released with the vertical, it gently it does not rub the floor. Okay. Find the maximum value of theta so that the sphere does not rub the floor. We have to find its maximum value. Basically, what will happen because of this mass, there is a force acting on the string of 4 meter length, and because of this stress, a strain will be induced on the string, and now this strain will cause elongation of the length of the rod. Now we have to make sure that this elongation is only up to 2 mm so that the ball just gently rubs the floor. Okay. So, and young modulus of the wire is given. Okay. So, let us just firstly write all the data given. Mass is given to be 20 kg. Then length of the wire is 4 mm. Then diameter of the wire is given, that is 2r equals 1 mm. Meaning r equals 5 into 10 raised to the power minus 4 meters. Okay. Now, we know at equilibrium, we know that T equals to mg. Tension in the string will be equal to force due to gravity acting on the mass. Okay. Now, we know this is the situation at equilibrium. So, let's move forward. Okay. When it moves at an angle theta and released, the tension at lowest point. Okay. Now, when it is released from this angle theta, what will be the tension at the lowest point? The expression for tension at the lowest point can be written as T mg plus mv square by r. It will acquire some kinetic energy because it was raised to some height in this when we when we pushed it aside to an angle theta, it was raised to some height and hence it gained potential energy. Now when it will return to its lowest point, there will be some kinetic energy induced to it, and because of the kinetic energy there will be some extra force in the tension. Okay, now the change in tension is due to centrifugal force. Okay, so basically the kinetic energy has caused a centrifugal force to act on it. Okay, this expression comes because of the centrifugal force. Okay, now delta T equals, because earlier tension was T equals to mg, but now the tension at the lowest point is what? T equals to mg plus mv square by r. So delta T comes out to be delta T equals mv square by r, mv square by r. Again, by work energy principle, by work energy principle. Okay. By work energy principle, we know that half mv square minus 0 equals to mgr into 1 minus cos theta. Okay, let's see where this equation comes from. So basically it is written that kinetic total energy initially equals to total energy in the final stage. This is the total energy in the final stage when all of its potential energy is converted to kinetic energy, as there is no potential energy because there is no height when the ball will reach at this point. When the extension is 2 mm, there will be no height left. Therefore, all of the potential energy would be converted into kinetic energy of the ball. So, from here we get V square equals 2gr into 1 minus cos theta. Okay, so this is the expression obtained from this. And how is this expression introduced? This expression is introduced on the basis of work energy principle, where we know that final energy is going to be equal to initial energy, and we know the initial energy is all potential energy due to height attained, but we know after extension of 2 mm there will remain no potential energy, only kinetic energy will sustain, therefore half mv square. And now from here we have this v square. Okay, so delta T we know is what? mv square by r. We saw it over here, delta T equals to mv square by r. So now we know the value of v square. So delta T becomes delta T equals 2g r 1 minus cos theta 2g m by r. Okay, this is what delta T is. And similarly it becomes 2 mg 1 minus cos theta. Okay, so now also we know that F acting on the string is equal to what? Delta T. F acting, the force causing stress. The reason of stress acting on the force is what? Delta T. Okay, so now F equals Young's modulus into area delta L upon L. So this expression is simply, we know that Young's modulus is what? Stress upon strain. Okay. Young's modulus is stress upon strain. Stress we know is force upon area. Strain we know is change in length upon original length. So from here, force comes out to be Y into A into delta L upon L, which is this expression. Okay. Now, next, this is force. Then we know that this can be written as 2m. Force we found out comes out to be 2 mg minus 2 mg cos theta. We can see from here 2 mg minus 2 mg cos theta. This is our force. Then we know Young's expression of Young's modulus is given in the question. So we also know how to deal with it. So let's just write y. The area is going to be pi r square. Radius is given in the question into delta L. Delta L is going to be 2 mm. So let us convert 2 mm into meters. So this is going to be the expression, and we know initial height is 4 meters. Okay. So upon solving this equation for theta, because m is given, g we already know, r is given, y is given, we just have to put the values in the equation, and the value of cos theta will come out to be 0.80, meaning the value of theta equals 36.4 degrees. This is our final solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.